Hello everyone, this is Stan. Hope you're all doing good. In this session, we are going to have a quick introduction about linear programming. So linear programming is very essential topic when it comes to competitive exams as well as in engineering polytechnic also. You have a subject called linear programming problem. And here in 12th standard mathematics, chapter 12 is all about linear programming. So I took this statement from 12th standard mathematics CBSE syllabus, chapter 12. So they have given a very nice statement. They are saying that the mathematical experience of the student is incomplete if he never had the opportunity to solve a problem invented by himself. See, linear programming is a concept which most of us are already practicing it. Maybe we never know that we are doing the problem or we are solving the problem using linear programming method. See, for example, if you are running a small shop or if you're running a big industry, so in your day-to-day life, in either it is a commerce stuff or even in an IT industry also, you might already be using linear programming. See, linear programming is a method in which you can derive a particular outcome. For example, how to save a lot of cost, how to get better outcome with less manpower. So how to store efficiently with the space that we have got. So how to spend with the budget that we have got. So these are all some real life, day-to-day life challenges that we generally come across. And for deriving that answer, we generally use linear programming without even knowing that we are using linear programming problem. But here what we are going to do is we are going to learn it in a very proper approach, in a methodological approach. So linear programming is a mathematical method as well. So we will learn it in a mathematical way. So when we are going to solve the linear programming problems, first we need to read the problem statement very carefully and we have to understand it properly. Then we need to identify certain elements like decision variables, constraints, and then whatever the important structural information in that particular question. So generally, what exactly is a constraint? Constraint is nothing but a limitation. Whatever restrictions, for example, we might have only this much space, we might have only this much budget, or we might have only this much time to complete this work. So these are all limitations or conditions or restrictions. That is what we generally call it as constraints. Okay, decision variable is nothing but it will be generally denoted in x, y kind of things, and it will always be greater than or equal to 0, especially in 12th standard mathematics linear programming. There is no negative values, so negative values will not be there for the decision variables. So, and also one more important point here. So these linear programming problems can be framed as a case study question also. So in your exam, for example, 12th standard CBSE mathematics exam, board exam, see, case studies can be either, I mean, we can expect case studies either from 12th chapter or even 6th chapter, right? So 12th chapter is all about linear programming. So you can expect a very good case study question. So let's understand this in a proper way. So linear programming is there in the industry for almost 80 years, 80 plus years now. So it was invented by Dan Singh in the late 1940s. And before we get into what is linear programming, so the word linear. So for example, if you have two constants like x and y, so generally it will be connected in a straight line. Okay, so that's why it is called linear, or there is a line in that word, right? So generally it will be a straight line. It won't be a curve, or it won't be a circle, or it won't be a bar. It will be always a straight line. So that's why it is called linear programming. And in a particular, see in this diagram, there are two different things, right? Vertex and vertices. So vertex is singular. The corner point is called vertex. And if you're talking about plural, then it is vertices. In a triangle, you'll have three vertices. In a square or rectangle, you'll have four vertices. And each corner point are called vertex. Generally, you can denote it by corner point, or you can call it as vertex. Okay, so not only this, you see, if you take a circle or a sphere, how many vertex are there? There won't be any vertex, right? Because it is a circle, it is a sphere. There won't be any corner points. So that's what it is, vertex or vertices. Okay, linear means there is the constants will be connected by a straight line. There won't be any curve, or there won't be anything like that. So linear programming or linear optimization is a mathematical method for determining the best possible outcome. See, what might be the objective? For example, what will be the better way of getting return on investment? How do we increase the sales, or how do we get the maximum profit, or how do we complete this work in a minimum amount of time? How you can efficiently use a particular space? So these are all the kind of best possible outcome that we will be dealing with, or that we will be challenged with. So manpower scheduling, production planning, so these are all the stuff. So as a manager, so this linear programming will help us a mathematical technique in our planning or decision making. So we can make a better decision using linear programming. So in linear programming, you will have some expressions, linear expressions like this, and it will be a combination of constants and some variables. So we will get to understand how you will get some kind of linear expression and how you can solve it in some of the questions in 12th standard mathematics. So now, before we go into the terms and terminologies, linear programmings are not only used in small companies, even it is used in big companies like automobile company like Ford, and the chips manufacturing company like AMD, Chevron, New York Life. So there are many big organizations which are practicing or which are using linear programming for solving whatever problems that they come across. Okay, so it can be used in many different industries. Manufacturing is one of the common use cases where we use this particular linear programming, and even in transportation also we might use this linear programming. So when it comes to linear programming, we need to be very much aware of these four terms or terminologies, but here I have listed six of them, but these are the four important. Okay, let's understand each of the terms one by one. So in a decision variable, so there might be two or three decision variables. Like in general, in 12th standard mathematics, there will be two variables that will be used. So these are the limitations, or the variables that we are referring at, or the activities that are competing with one another. So there will be two different stuffs like x and y. So these are the variables that will be competing with each another, I mean one another. So that is what we call it as linear here. So then constraints is nothing but the limitation. I already explained about the constraint. It can be a labor shortage, or space shortage, or availability shortage, or raw material shortage. It can be any restriction, even in terms of transportation or manufacturing. There might be a lot of different examples. So constraints are nothing but the limitations or the limiting factor that we have in our problem. So objective function, what is the objective? What is the maximum that we are going to get, or what is the minimum time that we can take to complete this work? So it can be either maximization or it can be minimization. So is what we are going to find out using this linear equation. So it can be maximization of the benefits or return on investment, or with minimal time, how we can achieve this particular work. That is what we are going to find out. And non-negative constraints, generally we will have two constraints, and it will be always greater than or equal to zero. It won't have negative values here. It will be always greater than or equal to zero. So most of the organization, either small or big, they are they will generally come across these kind of problem when it comes to planning or optimizing their available resources. So either it can be maximum production or maximize profit, or in some cases we might have to complete the work in a minimal amount of time or minimize the cost of production. So we will be dealing with this kind of issues very regularly. These kind of problems are very normal in many industry vertical. So there are many ways to solve this. So graphical method is there, simplex method is there, duality method is there. So here mostly we are going to deal with the graphical method. So one important point, see in exam when you are dealing with this, you might not when they give the answer sheet, you might not have enough graphs to uh, draw this and get the answer. So you might also practice in a white sheet also, so that you can be better preferred for the exam. Okay, so we need to, in the graph, we need to find two different things: feasible, infeasible region, or they call it as bounded, unbounded. So I will explain about this in a very soon, so don't worry about that. So optimization is nothing but constrained thing. In a given space, or in a given particular budget, how we can optimize and get better benefit. That is what we call it as optimization. So when it comes to linear programming, so there will be minimum two or three variables that will be given, and there will be multiple constraints in that particular question. and then we might also have a objective to find. So these are the three different ingredients in your question. So you'll have two variables, x and y, and you will have some constraints like budget constraint or space constraint, and you might also have to find the objective will be to find the z, which will be either maximum or minimum value. So we need to find the points first, and using that we need to find the inequalities and then go with the maximization or minimization of the quantity. So here we will find the conceptualization. So we can use this particular linear programming in manufacturing problem, diet problem, transformation problem. See, when it comes to manufacturing, let's say like you have a production line where you want to have maximum productions with limited raw material or with limited storage space or with limited labor force. How do we maximize the production? How do we maximize the outcome, right? That is what we generally come across in manufacturing. In diet, see, diet is interesting, right? So you go to dietitians or nutritionists where they will be giving you a health or diet chart. So they have to prepare it, right? And for human body, they need to have include proper amount of proteins, vitamins, and so on. So the diet chart has to be prepared in a efficient way, and also on the other side it has to be at a reasonable cost. So not everyone can afford high or costly foods, right? So in diet also you can use this linear programming where you can identify what is the minimum amount of available nutrients, and how do we minimize the cost with the diet plan, and so on. So diet problem also can be solved using linear programming method. And in transportation also we can use this method. So there might be multiple route to reach a particular location, or multiple options to send that particular product. So we need to identify which supply method or which demand pattern is better option. Okay, so solution can be one or more than one, but we need to find out the best possible solution. So in the earlier slide, we were talking about feasible, infeasible, or bounded, unbounded, right? That is what I'm going to explain in a diagrammatic method here. So in general, we'll have a x-axis and y-axis in a graph, right? And using that, we'll be finding the corner points. That is what we talked about as a vertices, or in we call it as vertex or vertices, right? So in plural, it is vertices. So here generally we will have O and then A and B, and sometimes you might have O, A, B, C and multiple. See, for example, here we have 4 corner points, and we might have more corner points in different scenarios. See, when the corner points are closed, for example, this region is bounded by 4 corner points, which are all having closed loop here. So which means this is a feasible region with bounded. Bounded means it is all closed. For example, in this particular example, we have 3 corner points, but not all the points are closed. See, we have a vacant area here. So then that means it is unbounded, it is open. Okay, so in some cases, you might also have an infeasible region. Okay, so infeasible region, unbounded, open area, and here in this example, bounded and it is closed. So bounded means the corner points are closed and it is bounded by corners. Here the corners are not closed, so it is called unbounded or open feasible region. So this is what we generally find in a particular question. So in a problem, right? In 12th standard mathematics, we have a very good interesting example, right? In mathematics 12th standard book, I could see they have a manufacturing related question or example in the introduction. So they have a furniture dealer who generally deals with only 2 items, either table or chair, and he has got only this much 50,000 as investment budget, and he also has a constraint in the storage space. He can store only maximum of 60 pieces. So generally a table costs 2,500, a chair costs 500, and then we are also making an assumption here that this particular company or person can sell all the items which is going to buy. So in the question, what they are asking us to do is they are asking us to have an optimization problem. So what they are asking us to do is maximize the profit using this budget and the space here. So that is what we are going to solve using the linear programming method or a linear programming problem. So thank you for listening. We will go through each and every question so that we get used to the problems that we might come across and the efficient way of deriving the problem.